We're now going to start the last chapter in this course, polar coordinates, vectors. We're actually going to talk about three pieces in this chapter. Sections 1 and 2, we're going to look at polar coordinates, equations and graphs involving polar coordinates. And there's a couple of videos already up online to look at concerning that. Then 9.3 is Des Moines theorem. We're going to look at complex numbers. We're going to look at complex numbers coming back to them, a plus bi, I being the square root of -1, and looking at complex numbers, but looking at them now in a polar idea, angles and distances. And it allows us to do some things that we can't do with a plus bi form. And then the last two sections, we're going to talk about vectors, directions and magnitude. And we're going to look at operation with vectors and look at dot product. We're not going to look at the last two sections. So what do we mean by polar coordinates? What do we mean by the polar coordinate system? Well, we're used to rectangular X and Y. And to move around there, you can go, every point, every ordered pair is left, right, up, down to get to it. Well, looking at points now polar, you have a pole. It's the same 0, 0. The origin that we call it in the XY plane is called the pole in the polar coordinate. And then the positive x-axis is called the polar axis. And so we want to find points. They're going to be in the form of r theta, where r is a number. It's related to radius. That's why they use r. And theta is an angle. And so from the polar axis, you measure the angle first. Positive angles are clockwise, counterclockwise. Negative angles would be clockwise. But you measure the angle, and now you have the terminal side. And on the terminal side, you walk out the distance r. And that'll give me a point, r theta. For example, if it was 2 pi over 4. We put the angle on first. Here's the polar axis, positive x-axis. We measure pi over 4, quarter way through the first quadrant. And then from 0, 0, we walk on the terminal side until we've gone 2 units, and we have a point, 2 pi over 4. That's how we find points. Now, if just like in xy, r or theta could be negative. So if r is negative, what you're going to do is from the polar axis, mark the angle. And then instead of walking on the terminal side, if r is negative, walk opposite the terminal side to get to your point. For instance, -3, there's r, 2 pi over 3. Polar axis, mark off r, 2 pi over 3. Second quadrant. And that's the terminal side of the angle. But because the value of r is negative, instead of going in the direction of the terminal side, you go the opposite way to get to the point -3, 2 pi over 3. And that's how you measure angles. That's how you plot points on the polar axis. 3, 5 pi over 3, r theta. So from the positive x-axis, the polar axis, you measure 5 pi over 3, which will take us into the fourth quadrant. And now you have the terminal side of the angle. 3 is positive, so we're going to go in the direction of the terminal side. And here's our point, 3, 5 pi over 3. Or 2 minus pi over 4. Terminal, here is the polar axis. Measure the angle first. Minus pi over 4 is clockwise. So we're in the fourth quadrant. 1/4 of the way, 1/2 of the way through the fourth quadrant. And then since r is positive, this is the terminal side of the angle minus pi over 4. So we go on the terminal side 2 units out, and we now have the point. 3, 0. 0 is the angle. So here is the polar axis, and the angle is 0, which means we go in this direction. So the terminal side, initial side are the same because we haven't moved. And we now go 3 in that direction, and we get 3, 0. Polar. -2 pi over 4. So from the polar axis, we might measure pi over 4, halfway through the first quadrant. That is the terminal side of the angle pi over 4. But since r is minus, instead of going in the direction of the terminal side, we go the opposite direction, and -2 pi over 4. That's how we do it. Now, unlike rectangular coordinate system, with polar coordinate system, we can identify the same point in a lot of ways. For instance, 2 pi over 4. So pi over 4 is 1/2 way through the first quadrant. There's the terminal side. So we go 1, 2 units in that direction, and we now have 2 pi over 4, and it's that point. 2, and now we have 9 pi over 4. Well, 9 pi over 4 is all the way around. That's 2 pi, or 8 pi over 4, plus pi over 4. And going 2 out the terminal side, 2, 9 pi over 4 arrives at the exact same point as 2 pi over 4. Or -2 minus 7 pi over 4. Here's the terminal, here's the polar axis. -7 pi over 4 means go clockwise. And you're going to go clockwise around pi, 3 pi over 2, till you get to 7 pi over 4. And then we go out 2 on the terminal side, and notice it's the same location. So there are numerous ways. Or -2, 5 pi over 4. So here is the initial side, the polar axis. 5 pi over 4 takes us into the third quadrant. So here is the angle. This is the terminal side. Here's the initial side of the angle 5 pi over 4. But since r is negative, instead of going in the direction of the terminal side, you go opposite, and you end up at the same point. And so the same point can be identified in a variety of ways using polar. And I'll do an example in a pencast so you can see that. But here's the summary, right? R theta. Theta is in radians, okay? And it can be represented by either theta plus 2 pi k. Again, remembering that this is once around. Every 2 pi is once around. So if k is 3, 6 pi, we're going 3 times around, and then plus pi. And that'll give me exactly the same spot as there. So r, theta plus 2 pi k, multiple ways of writing the same angle. Or minus r, theta plus pi plus 2 pi k. Well, theta, put the angle on. Pi would be halfway around. 2k pi would be as many times as k is, back to that spot. And then minus r, go the opposite direction than where that angle is, and you would be at the same place. Those are the ways to find polar coordinates. But what's the relationship then between polar and rectangular? Well, a couple of conversions. If we're given r theta, I can change it back to xy by using these two formulas. So r cosine theta is the x value. R sine theta is the y value. So given r theta, I can convert it back to xy by using those two formulas. Learn those two formulas, memorize them. They'll come up in a lot of applications later on. So memorize those two pieces. Right? So again, if we want to convert, here's r and theta. So to convert that to xy, right? X is r, 6, cosine theta, cosine of pi over 6. Cosine of pi over 6, one of those guys you're supposed to memorize in the very first part of our course. Square root of 3 over 2. And so x is 3, the square root of 3. And then y is r sine theta. So 6 sine of pi over 6, or 6 times 1/2, which is 3. So 6 pi over 6 in polar is the same as the 3, the square root of 3, 3. And again, if we look at that, here is the terminal, the initial side, the polar axis. We measure pi over 6, and we go out 6 units, and we end up with a point there. If we went 3, the square root of 3, and up 3, we arrive at the same point. Two ways of saying the same thing. And again, we'll show more examples on that as we go along. And we'll show more examples of that as we go along. Okay? So, converting from rectangular coordinates to polar, we need other formulas to go from rectangular to polar. We need some other formulas to do that. And how to convert from rectangular to polar? Okay. Again, use the polar coordinates, put them on there, and then in this case, 0, 3. Okay, that's the rectangular coordinate. 0, left and right, up 3, we get to that point. XY is 0, 3. Well, we already could know then that that angle is pi over 2, and the distance up there is 3. So 3 pi over 2 would give me that result. But so would minus 3 minus pi over 2, because if we went minus pi over 2, we'd be down here. Minus 3 says go the opposite way, and we're there. And so when we are changing from rectangular to polar, when we are changing from rectangular to polar, there may be multiple ways of doing it. Multiple ways of doing it. Now let's just think of the ones on the polar axis, on the XY plane here. If this is the point, A0, that's what that point is in rectangular, A0. Well, the angle is 0, the distance is A, so A0 and A0 in XY and in polar are exactly the same. If we have it on the y-axis, R0, or 0A, sorry, 0A, because you go 0 left and right, you go up A, you're right there. Well, that's going to be the angle pi over 2 and the distance A, so A pi over 2 is on the y-axis. We're over here. Okay. That distance is 0 minus A. 0 minus A. That angle is pi. And in the direction of pi, so minus A 0 in XY is going to be A pi. And this point, which is going to be 0 and minus A, that angle is 3 pi over 2 in that direction is A, so A 3 pi over 2 gives us that. So there's some relationships. Well, what is the relationship then between polar and rectangular? Well, here it is. Things you already know, right? That if you're given X and Y, we can find R by the Pythagorean theorem. Because if you look here, for example, if this is X, Y, we've got a triangle. And R is the hypotenuse of that triangle. So R squared is X squared plus Y squared, which means R is plus or minus the square root of X squared plus Y squared. Not unique going to polar. If, again, in this triangle, the angle, this is the Y is the opposite side, the X is the adjacent, that's tangent. So the tangent of the angle is y over x. So using those two formulas, we can convert from rectangular to polar, from polar to rectangular. So steps for converting to rectangular. Always plot the point, x and y. Do that first. Left, right, up, down. Plot it. Note the quadrant that the point lies in or the coordinate axis. So if x is 0 or y is 0, then that means that r would be the square root of x squared plus y squared. And if x is 0, the angle is going to be, we're not going to go left and right, so the angle is going to be pi over 2 or 3 pi over 2. It's going to be, if the angle, if the y is 0, it means we're going to go up and down, and so that means that x is 0 or pi, and there would be r. Okay. Now, if x equals 0 or y equals 0, okay, if that's not the case, right, x and y are not 0, then find theta. It's going to be the tangent of y over x. And from graphing, if you graphed it in the first and the fourth quadrant, the tangent, the angle, will be just the result there, because the inverse tangent lives between minus pi over 2 and pi over 2, first and fourth quadrant. If it's in the second or the third, then find theta by taking the arc tangent of y over x, and then add pi to it, and it'll be the fourth, the second and the third quadrant pieces. So that's the technique. So first part of this section, changing from rectangular to polar, from polar to rectangular. The second thing we want to be able to do is talk about equations. R equals 6 cosine theta. That is an equation in polar. When we try to do equations in polar, we like, if we can, to solve it for r. Just like in x and y, we try to solve it as y equals a function of x. So when we can, we're going to make it r equals a function of the angle. Now, because of our relationships, x squared plus y squared is r squared, right? If I would just square both sides of this, right, then I end up with cosine squared, and I don't want that. But if I multiply both sides by r, again, I'm allowed to do that. Same thing I can do in any equation. If I multiply both sides by r, I get r squared, and I get 6r cosine theta. X squared plus y squared is r squared. So we can substitute. R cosine theta was x, and so we get x squared plus y squared equals 6x. If we are transforming from rectangular to polar, for example, we have 4xy equals 9. Since x is r cosine theta and y is r sine theta, then 4x r cosine theta times y r sine theta equals 9. We get 4r squared cosine theta sine theta equals 9. And we've done the conversion. We can fix that a little bit, because cosine times sine is related to the double angle. Since we had 4 here, I can take 2 and 2. There's still 4. So 2 sine theta cosine theta is sine of 2 theta. So we get 2r squared sine of 2 theta equals 9. And we've converted it into polar. Now notice, this doesn't solve nicely for r. When it does, we do that. So there's your information. The key pieces of that in here is that you need to know that if I have it in rectangular, I know x and y. I can find r and theta by using those two formulas. I can use r and theta by those two formulas. If I have r and theta, if I have r and theta, then I can convert it to x and y by using these two formulas. r cosine theta is x, r sine theta is y. So that's what's in section 9.1.